Lucio, vielen Dank. Do you speak English, no? Thank you very much for the invitation. I'm very happy to be here again. I was here so many times, and I found out I have the same chairs at home. I stole them from our office. And what I will be talking about, reverberation of Frei Otto, the Nachhall von Frei Otto, is actually based on a lecture I gave at an event that Eckhard Ramm organized in 2017. So I have to hold it so close. Okay, I'll do my best. Reverberation, Nachhall of Frei Otto, where? At Schlaich Bergermann, because Schlaich Bergermann is one of these offices, engineering offices that follow the Stuttgart School of Engineering. And since I know SBP best, I decided to look what happens actually in our office regarding Frei Otto. And I think it's always an interesting exercise to try to understand where your ideas come from. What is the source of inspiration? How has all this happened in general? So where do we come from? This was, I think, quite an exercise. And obviously, our history, the history of building, is a history of materials. It's a history of analysis. And whenever there was new materials, whenever there was new calculation methods, there was progress in structures, so to say. But there's also social, political, ambiental changes that change the way we build. And then I think progress can also come from inspiration that we get from others. And this is what I want to talk about. Looking at Schlaich Bergermann, we follow a certain corridor of ideas or principles. And when I look at my father and Rudi Bergermann, I'll show them in a second, when they opened the office 45 years ago, something like that, they got a lot of inspiration from simple objects. The salad sieve, the spokeswheel, all that, has entered our structures. But then also, it's paying tribute. It's the homage issue, understanding our heroes, drawing inspiration from Buckminster Fuller, Maillard, Eiffel, all these heroes on whose shoulders we stand somehow appear in your work consciously or unconsciously. And there's this phrase that I heard for the first time from Bill Baker, but I'm sure it's older, which says, good artists copy, great artists steal. And I think in our office, there was a lot of stealing in the sense that progress comes from taking ideas and taking them further, not copy paste, but translating them in our times, using today's materials, using today's possibilities. And then I think theft is okay. So I want to, after this rather lengthy introduction, I must tell you that I have 20 more. No, this is not fair. You took some minutes away already, Lucio, no? I have 60 slides, and I'll show you that I can do this in 20 minutes. So these ideas will appear in this talk in a way. Let's see where we have copied, where we have stolen, where we have drawn ideas from elsewhere. For me, that was quite eye-opening, and perhaps these ideas that I present can be translated to elsewhere. So today, Schlaich Bergermann is all over the place except for Africa, but that's a different story. We are 6 partners and fortunately 6 friends. And we have roots. You always have to find out where do you come from, as I said. And one of our roots is certainly the second Hooghly Bridge, indigenously built. My father talked so much about it. And ever since then, we are doing a lot of bridges. Another route is definitely solar energy projects, the famous Aufwindkraftwerk, solar updraft tower that was never built. But some projects become famous even though they're unbuilt. And then comes the perhaps main, or yeah, let's call it the main route, the Olympic Stadium roof that I know only through my father. You know, he was from Monday to Friday, he was there, and I saw him only on the weekend. And it started like that as a Danish design, and it's always here. So if you have questions, here's the man who also knows very well. But it started with this peaky story, and it showed a different Germany. It showed an open, transparent, elegant Germany, not the Germany that was the buildings that we saw until 45. And here's the group. Some people say it's the other way around. It is, okay. So, well, here's an historian, so she should know. Next time I'll show it the other way around. But anyways, Heinz Isler, by Otto, Jörg Schlaich, Fritz Leonhardt, Rudolf Bergermann, and Knut Gabriel, all these were involved in it. Actually, Frei Otto was involved only for a couple of months in this project, but he had a big influence. So it's not peaky anymore. You see, the roof is now hanging, and also the initially vertical masts are now inclined. So there was quite an influence in his short stay in the project. And this has influenced our office ever since then. My father worked on lightweight structures, and now you have seen these books, or you have heard about it yesterday. Otto has produced so much in writing, but not so much in building. But basically, it's impossible to invent anything in our field, in our business, because he has invented everything already. But at least we can still build the stuff, you know. So let me take some of these books, 7, and we start with Netze und Natur. And here comes the Dorton Arena in Raleigh that inspired Frei Otto, that you heard about it yesterday, you know, his doctoral thesis, the 74 book, and the reprint later. And I think this has inspired then a lot of German engineers. This arena with the two, no laser? It doesn't work well. Okay, there's a compression ring here, there's a compression ring here, and then there's hanging cables. It's an anti-clastic double-curved cable net, in that case covered with concrete. And the rings are in compression, and they work nicely for pre-stress and permanent loads, but the facade is needed for unbalanced loads. You know, that then it goes, if there's snow on one side, you get tension or compression in the facade. Together with Crafts Architect, we stole this idea and left the facade. So it's nicely balanced for all kinds of loads, but then for unbalanced loads, the ring has to take it. It's a double curved cable net, as you can see here, the saddle shape that works in a way so that that there's only compression here. You don't get any bending. That's the idea. That's how you get it lightweight, at least as I said, for permanent loads. And you can do this with two layouts, let's call it this way, with an orthogonal cable net with horizontal and vertical pre-stressing, or with the radial approach, the spokes wheel approach. I'll talk about that in a second. Anyway, so that is definitely and consciously influenced by Severud's Dorton Raleigh Arena. And we did yet another one here in Schirke in the Harz. It works nicely. It is doing well, and it covers large areas. Just that we used membrane instead of concrete. And then afterwards, I found out that there's this building, which I had not known before, the St. Lucas 1964 church in Bremen. Here's a model from to analyze the forces in the geometry. And it was actually built like that. And the nice thing here is that Frei Otto has actually used, that's by Frei Otto naturally, this is the facade here is actually a cable net, as you can see. Cable nets. Frei Otto has worked in the 70s on cable net cooling towers. Actually, I think tried to patent it. And it's a very nice structural system. You see a compression element that branches out, and then from here, from the tips of the branches to the foundations, you stretch, you tension a cable net. So you get a double curved, highly stiffened cable net. And perhaps here we have to ask the historians, perhaps there was a race, because at the same time, basically the same year, Kühlturm Schmeehausen was built in 74 by Jörg Schlaich, which is also a cable net structure. It's a bit different because the stiffening is done with spokes and spokes wheels and compression rings, but it's again a double curved net. Could I get a glass? Oh, there's one. Thank you. Yeah, because I'm in a rush, I cannot pour water. Yeah. So this is, here you see the two, the concrete shell, double curved, classic cooling tower, and here the cable net cooling tower, 180 meters, imagine. You see the Christmas tree, basically, the compression element, and then the radial cables and the compression ring, and then the tensioned cable net and an aluminum cladding. He tore it down in 1991 when the power plant was not needed anymore, unfortunately. Just seeing it makes me feel better. So membranes. You know this one? No. This is, according to my record, it's the Allwetterbad in Regensburg. It was a movable structure. You see a mast, and from the mast you see the cables, and these cables are connected to a membrane, hold the membrane, which in turn is then stressed into the ground. No? Have a look, store this image, your brain. This is the inside. So here you see the anchorage points where all the cables are connected. Naturally, you have to strengthen the material, you have to strengthen the membrane, long story. Where's this? That's Kuala Lumpur, 3 times as big by Schlaich Bergermann partner. At mast 100 meters high. This is how it looks inside. Well, there is some similarity, isn't it? But so this was, and what is the I say this, the drawback of these kind of structures is that you have to anchor them in the ground like a tent, with Heringe. You have to stress it into the ground. The advantage of this system here is that you don't have to, it's self-anchored, and that is very attractive. And this is, let's call it stolen again, stolen from SOM. I think SOM with this arena in closest, where was it? I have to look it up. Oakland Arena, California. That was one of the first spoke wheel structures, large spoke wheel structures, compression ring, radial cables, but then a concrete cladding. It's a hanging roof, actually. So here you see it from the side. So 50s, concrete, heavyweight, radial cables. And now comes the Neckarstadion, which has changed names 10 times by now. I just stick to Neckarstadion, that's easier. So here, this is the first big spokes wheel or loop cable roof, modern loop cable roof, 1993. You can see the compression, you can imagine the compression ring, the tension ring, Belge, Nabe, and the radial cables, the spokes. And as a proud designer, you stand on top of it, and you can stand on the membrane, but you can see we all stand on the arch because that's a bit safer. So trust your structure. So, and ever since then, we have done dozens, I think 40, 50 of such cable systems, while the Olympic Stadium roof is not really repeated because the anchorage is so expensive, And when you have cable nets, you have to cover the cable net still. So membrane structures are a bit easier, I would say. And this is the latest of our structures that went up 2 weeks ago. This is the so-called big lift. When you lift the ring cable, that's the stadium of Tanger, because this is where the next soccer world championship will be. Actually, I can slow down now because I see I have still 10 minutes. So we go to pneumatic structures, which is also very, very nice, very attractive, because pneumatic pre-tensioning, stressing a synclastic double-curved membrane with air is very efficient and leads to the perhaps most slender structures at all, you know. And Frei Otto has known about that, naturally, because he wrote this book, but he has worked in the 1970s already. When he was in Yale with his students, he developed such inflated membrane structures as models. And from what I know, 1 or 2 of such inflated membrane structures were actually built, like here the laboratory in Cologne in 1966. But at the same time, the Japanese were very strong. Perhaps you have heard of Mamoru Kawaguchi. Those were the membrane guys. Those were the inflated membrane guys. And you could talk for hours on the Fuji Pavilion in Osaka, 1970, which I think is wonderful. And if you look, you know that Osaka is hosting again the expo right now. And if you compare what they did in 1970 and 55 years later, I feel very sad. It's not very inspiring what you see there, just a lot of timber. But in 1970, there was really, really brave stuff going on. Anyways, I can also offer my own personal bubble, which is this one. It covers a bullfight arena in Madrid. They like bullfights there. And it's a shell structure with a bubble inside with 50-meter diameters, double membrane. And you see these little sticks. On these sticks, you can pull it up and down. See, it goes up like that. And then all of a sudden, they smoke cigars during the bullfight. So it's important that you lift it and then the air goes out very quickly. So you can do this whenever you want. So, and this is how it looks from the inside. It actually, since you're sitting on an inclined level, or since the how do you call it, the grandstands are inclined, you can actually see nicely some sky, even so you lift it only by 12 meters. So now we have reached movable structures. And this is perhaps the worst for today's engineers, because really everything was invented by Frei Otto. There is, if you look at his sketches, basically everything is there, you know. And Frei Otto was thinking big. If you look at this one, I'm not sure if this would survive a wind tunnel test. You see this huge stadium and then this membrane coming down, covering this beautiful membrane coming down, covering this huge space, and it covered also the book of catalog that Winfried Nerdinger did in 2005. You know, you can see it here. Frei Otto built one of these roofs. This is the theater in Bad Hersfeld, movable. You can see that some people always react when they see the picture. I know this one. I was involved in this one. It's so nice to see that. You know, there's really some interaction here. So this is a ruin. You can also see the mast here. And from the mast, again, the membrane is lowered. Now look at this picture. This is the membrane coming down, stored. And now look at this picture. Where's this? Montreal. No? So you see how this, at least Schlaich, Jörg Schlaich was involved in that at the time. This stadium was much bigger. And from what I understand, it never really worked. A lot of trouble. Materials were just not as advanced. You know? Mechanical engineering was not that far. So later they built a fixed roof on it, but they kept the tower and the cables, and actually now there's work again on this stadium. But today, with today's materials and today's mechanical engineering and with today's software, you can do that. That's the roof of the National Stadium in Warsaw. You see a central spokeswheel and an outer spokeswheel, and in the middle, the central needle holds a huge piece of membrane in a basket. You lower the basket and you pull out the membrane, and you can cover 12,000 square meters of central stadium roof. So this today is possible. And you see the connection here again, you know. There's sometimes, you know, it's directly taken, sometimes it's influenced, sometimes it comes from elsewhere, sometimes there was a race, sometimes it's completely independent. But it's very interesting to see these different tracks. Grid shells. Who did the first grid shell? I would say Eduardo Torroja at the Fronton Recoletos in Madrid, because he understood that you can discretize a continuous shell if you use triangles. So to me, this is one of the first modern grid shells, triangles. Frei Otto naturally is famous for the Mannheim roof, a quadrilateral grid shell that is again based perhaps on the idea of the Olympic Stadium roof net, because there you have, it's not a triangle, so that the joints can move, you can get rotation. And that was clearly, I don't know how you say it. It was not stolen, but it was really, it came to life again. Let's put it this way. In Neckarsulm, because this Neckarsulm grid shell follows the same idea, but it was not very clever for glass because you get double curved glass, which makes no sense, you know. But here you can see there's cables that stiffen it, so the triangles appear again, triangle, triangle. And Frei Otto did this stabilization with long cables, and then he used a membrane to stabilize the quadrangles. In the meantime, we have developed this further. There's Hans Schober's famous translational shells, you know, so there's a whole story going on, but it all started from these early grid shells. You know, there's a lot of inspiration that can be drawn from these heroes, from Torroja all the way to Frei Otto. But here, this is a comparatively late one, but it's also 20 years old already. This is a translational Hans Schober grid shell. Or here, yet another one, Sauerbruch-Hutton Architects again, a translational shell where all the glasses are plain, and that makes it much cheaper. So now I have 2 minutes left, and we go to trees. And again, Yale students, from what I understand, you see, we try to put the sources, but we did our best, but I cannot always guarantee that we are right, you know. But from what I gathered, this was again student works from Frei Otto's Yale times. And where do we have such trees very close to here? Flughafen, here we go. No? This is Stuttgart. Some striking similarities. Trees make, at first sight, no sense in building, because trees are optimized for maximum surface, for wind resistance, and trees in buildings are more for minimizing the spans at the roof and maximizing the distance of disturbing trunks at the base. So it's a different approach, but valid. Last one, climate shells. Frei Otto was ahead of his time. Sometimes also in a weird sense, you know, he wanted to, this was climate shells for mining in the Arctic. So mining in the Arctic is not so sustainable from today's point of view, and he wanted to heat it all with nuclear power plants, which we perhaps also would not find so cool. But he had this idea of producing large domes, very much like Buckminster Fuller, who did his dome, proposed his dome for Manhattan, and who said that rather than having the surface of all the buildings in Manhattan, I have one dome which is then much less surface than to heat, so to say, or to insulate than the individual buildings. And this appears here again. And we are working on that at the university also, climate shells here. This is a Schulungsgewächshaus where people get taught and grow, and plants grow, and the plants produce the O2 and for the people, and the people produce the CO2 for the plants. So the reverberation of Frei Otto at Schlaich Bergermann partner was a quick run. I hope you enjoyed it. I'm at minus 20 seconds, so more or less. But I think it's important to do such kind of thoughts, you know, to understand where you come from, where do your ideas come from. You can actually make this an exercise and rehearse this and do this in a meaningful, conscious way to develop ideas that you have seen from others in times where they did not have the means. Take these ideas and translate them into our times. Thank you very much.